related to design and construction was improved at 95%. More well-designed design where simulation and analysis was increased by 85%. And BIM had about 85% beneficial impact on project schedule and 72% greater predictability of construction cost. So connected BIM can help you address business challenges that you're facing today. So what are those challenges? The first challenge is win new work. You will be able to win new work. How will you be able to do this? By meeting client demands for BIM deliverables, because many clients now are asking for BIM deliverables. So when you adopt BIM, you're catering to your audiences, you're catering to your customers, so you'll be able to win more work and effectively communicating design intent to earn stakeholder buy-in. So you can communicate your concepts, you can communicate your designs at an early stage. You can communicate your design intentions to all your stakeholders so that you can get a buy-in, which will give you a benefit from the other contractors. You will also be able to deliver higher quality designs by improving building performance via analysis tools and using visualizations and virtual reality to experience your designs even before they are built on the site. And the third point is you'll be able to work more efficiently. And how will you be able to do that? You'll be able to do that by reducing errors and change orders and improving collaboration with engineers and contractors. And finally, you'll be able to expand your billable services by extending service beyond and into building operations with model maintenance and recasting your advisory relationship with clients to deliver the long-term value that all of us are interested in. So the unique portfolio of BIM technology in Autodesk supports end-to-end workflows across the building disciplines, right from project's conception to completion. And all of these solution sets, they work together to provide validation of your most critical design decisions. With these Autodesk tools, you can begin BIM workflows even at the conceptual stage of design. Analysis tools are built right into a building BIM authoring application, making it easier to make high performance building design an integral part of your design process. Our integrated visualization and virtual reality capabilities give you unique insight into what your design will look like in the real world and allow you to experience it well before the construction begins. And finally, our cloud-based collaboration tools help you put projects at the center of the design team. What this does is it provides team members access to most up-to-date project data whenever they need it. So let's take a look at a series of tools and workflows optimized for the conceptual design phase. As you know, we are going to talk about all of these design phases now, right from conceptual design, then move into schematic design, design development, and documentation. And we'll cover all the tools that you can use in each of these different phases. And we'll also uncover how these tools are connected to each other and the data is connected between these tools so that you don't lose data when you move from one phase to the other, and it is all seamless. You don't have to stop and start again. It is all once you start at the conceptual design, you can go without any stop. You can go as a seamless flow from concept to schematic to design development to documentation. So first we'll look at a series of tools and workflows optimized for the conceptual design phase. So with Autodesk tools, the BIM process starts at the earliest stages of the design. And this is the most important stage for us because we know how a typical construction project works, right? When we go later into the project, when we have design changes that occur later into the project, the cost and the schedule impact that those design changes will have is also on the higher side. But if you have those design changes or if you have those concepts or designs finalized at a very early stage, the impact that it is going to have on the cost is actually going to be a saving for you. It is going to save you cost. It is going to save you schedule. So how can Autodesk solutions help you understand this early process of design? So Autodesk tools will help you start this design at the earliest stages and carry seamlessly through further stages of development, avoiding the need for remodeling at a later stage. You can sketch in 3D, collaborate on concepts as a team, analyze the potential building performance, and iterate on designs fluidly. And you can capture your design ideas whenever and wherever they strike on your mobile application for iPad and Android. BIM-based conceptual design that I just mentioned starts in Autodesk Format Pro, which is part of the AEC collection. using Format to develop early concepts, massing, conduct energy studies, and conduct conceptual design reviews with the team or with the clients. Once you're ready to take your design further, you can seamlessly transition your Format data into Revit using the cloud. You don't have to worry about remodeling it or starting the model again from scratch for the design development stage. Once you create your concepts in Format, since all of these tools are connected together, you can seamlessly transfer that model into Revit for your further development activities. So we'll see that in action now. So in this example, we are looking at working with Format in a desktop environment and importing a 2D sketch from AutoCAD into Format in order to create a 3D massing model using Format geometry toolset. You can see how simple it is to sketch the podium and the tower forms and extrude them into a massing model. You see how easy it was to extrude it. Once the forms are extruded, it is possible to then specify the project location as well. And with the project location set, a map appears in the view and we can adjust the location of the massing to the correct place in space. See how easy this is. You can move it to your desired location once the location is set. And to further articulate the forms, we can add levels that will translate into Revit models. So you can use multiple levels which we can then import into Revit. You can see how simple it is to import Format geometry into Revit and continue to develop your model from the schematic design stage through the design development stage. So this is the power of Format for your conceptual design and then transferring the model into Revit for your design development stage. Beyond the desktop, Format is ready for design on the go with advanced tablet workflow capabilities as well. Here we're looking at an iPad Pro and Apple Pencil workflow. Setting location allows you to gain a better understanding of a building's site microclimate such as annual winds and temperature patterns. This also sets the stage for shadow, solar, and energy analysis. You can also import a scaled satellite image to provide an accurate basis for 3D sketching. Format 360 can import a variety of file formats useful for bringing in site models and other resources. Familiar natural gestures are used to navigate the model, while the Apple Pencil greatly improves the accuracy of 3D sketching. Applying pressure on the pencil locks into the current axis and you can use surrounding geometry as a reference. You can use Format 360 to quickly generate and evaluate design options. Custom bitmap materials will allow you to visualize how the buildings will appear. We'll see that in action now. I'm just using the pencil here to use the pressure sensitive displays to change my geometry and generate different flows from the geometry that we just created and adding materials using JPG files or image files that I have. You can also see how the shadow will affect surrounding buildings and open space. The solar analysis tool will provide insight into the best strategies around shading the facade and even potential for solar panels. Format 360 works with Insight 360 to give you a deeper understanding of many energy use factors early in the design process, while many significant changes can still be made without having a huge cost impact. You see the Insight 360 integration right here. See the building orientation graphs, operating schedule, the energy efficiency of your building, all of that can be taken with Insight. And finally, all designs made in Format 360 can be seamlessly imported into Autodesk Revit, the industry standard application for building information modeling. With Format, data is seamlessly carried over from concept design to design development and integrates with Revit. You can work in a standard desktop setup for concept development driven by architectural sketches. Or if you choose, you can work on the go and directly in the context of the site, both physically and virtually. This gives you a better insight into development requirements. And what if you could use the power of computing? We spoke to you about computing, computational power and computational analysis. What if you could use that power to rapidly generate multiple design options and find optimal solutions to design challenges? We say we developed a lot of concepts, we developed many alternate designs, but what if we can use software to automate those tasks and give you efficient design ideas? Many architectural firms are embracing computational design tools for this purpose. With computational design, you can more rapidly test, iterate, and study numerous design options. You can model more sophisticated design geometry using simple data, logic, and analysis, and also save time by automating repetitive tasks. Autodesk Dynamo Studio helps architecture firms gain the benefits of computational design all through a visual logic environment. Please understand that there's no programming required. You can work with Dynamo within the Revit environment or untethered from Revit using Dynamo Studio. As you know, Dynamo is also built into the Revit platform, but if you want to work separately, you can also use the Dynamo Studio, which is a standalone application. Dynamo's broad interoperability with other tools allows for maximum flexibility in implementing Dynamo into your BIM workflow. In this example, we are looking at an early stage design study where we are testing a variety of variables for a rectilinear massing model to optimize the tower return on investment by way of Dynamo. You can see that it is possible to flex the parameters with sliders in the Dynamo environment, and in turn this flexes the geometry for the tower height. Also, the tower floors, podium, and even setback driven geometry. Levels are defined within the Dynamo environment, and as the mass that we have created using Dynamo is brought into Revit, it is possible to generate roofs, walls, and floors from the conceptual study in Dynamo. Here's a look at how Dynamo can be used to easily create and iterate complex geometry. In the stadium project, we are seeing the flexing of an arc radius parameter with a number slider to drive the big picture design in an iterative geometry study. Using number sliders, it is possible to change the number of risers in the stadium and allow this parameter to drive the overall height of the stadium form. Trusses are added to the design through Dynamo in an iterative process, and you can even review the details of the truss data in generic model schedule in Revit. Multiple options are studied and a panel system is even added to the underlying structural study as part of automating the process using Dynamo. Design validation is integrated into the Dynamo graph, and it is possible to run a solar orientation analysis that appears in a color gradient on the surface of the panel system. Further, big picture geometry iterations may occur while the graph is under development. And what you see here is the final study as brought into the Revit environment and ready for design development and documentation. Moving on, talking about more about the conceptual stage. We see a number of people who are working on renovation projects. We know many of you also work on renovation projects. It is easier than ever to implement BIM on renovation projects thanks to the increasing accessibility of laser scanning and data preparation tools. Using BIM on renovation project allows you to design with greater precision, helping to avoid issues that may arise when 2D design files don't actually reflect the as-built conditions. And we have seen that happen across many industries, across many organizations, where whatever the as-built situation is, it is not represented accurately in the 2D drawings that we prepare. So it also speeds the design and documentation process and allows you to provide a more accurate model of as-built conditions to the project owner for use in the operations and maintenance phase. Autodesk has created a powerful and easy to use workflow for reality capture in order to bring you a scan to BIM workflow. So what is a scan to BIM? We'll see that in detail as we go on. Autodesk has partnerships with every major hardware vendor, including both unmanned aerial vehicles like drone manufacturers and laser scanner manufacturers as well. Recap Pro has been designed for use by someone with no previous experience, so it's very user friendly. And one-click automated workflows do powerful tasks like scan registration, which stitches multiple scans or multiple pictures together into one point cloud data. Intelligent cleanup services automatically remove unwanted noise that we usually get in a scanned file. Like a person walking through a room with being scanned, it will automatically remove all of that. And perhaps most importantly, Recap integrates with all of Autodesk AEC design creation tools, including Revit. With Autodesk Recap, you can create a scan to BIM workflow to create elevations, floor plans, and 3D models from scanned data directly in Revit. And once and once the once the scanning process has been completed, you can define regions in Recap that can be used to define level heights and elevations in Revit. You see the scan data that is being brought into Revit directly. So you're not creating a 3D model from scratch. You already have a basic 3D model that you can work with. We're just going to add elements to it so that already existing project or a brownfield model can be brought into Revit directly through the scan to BIM workflow. The same scan data can be used as a reference point to create floor plans. You can simply use the Revit's intelligent modeling tools to define furniture, walls, doors, and windows, complete with accurate dimensions. You can even add more detail to your design, such as customized stairs based on the scan data that was captured. And after all of the existing buildings are modeled, you can make new additions to your Revit model for retrofit and renovation purposes. Now let's take a look at a tool and workflow optimized for the schematic design phase. This tool will capture the schematic data and work to validate your design solutions. Recognizing the long-term environmental impact of buildings, sustainable design is an imperative for many architectural firms. Autodesk BIM tools make it easier than ever to incorporate your sustainable design decision making, even at the earliest stage of design. Our powerful analysis tools use leading simulation engines for whole building analysis, including energy, cooling, heating, daylighting, and solar radiation. The tools also provide a mechanism for architects to work with owners to better monitor building performance and the cost during its operation. And what better time than now to implement this tool with the AEA 2030 commitment in adoption by the AEC firms. Integrating sustainability into the design process with a sharp focus on energy performance prioritization during the design phase is a critical aspect of this initiative. In this context, Insight allows you to drive client value and cost savings through energy modeling and combat the effects of global climate change. So Revit includes direct access to building performance analysis using Autodesk Insight. It is a plugin that you can access directly from the Revit environment. You don't have to use a third-party tool or something like that. With the push of a button inside Revit, you can send your Revit model to the cloud for analysis. And the results are quickly returned back to you in a visual, easy to read format, making it easy to identify opportunities to improve your design at the early stage of your process. Autodesk Insight helps you discover a fast, intuitive, outcome-driven guide to better building energy and environmental performance throughout the building lifecycle. I've just opened the Insight plugin here. Insight enhances Revit and enables you to visualize and interact with key performance indicators, benchmarks, factors, ranges, and specifications. So this is similar to the one that we saw earlier using Format. It is the same plugin that is also available for Revit, where you can do the energy analysis with real-time cause and effect feedback to guide you towards better outcomes. See, once you run an analysis and the analysis is finished, you can access this in Autodesk Insight, where you can change the design options for better performance. See all of these different analysis that is available within Insight. You have lighting efficiency, daylighting, and occupancy controls. So what happens is we are able to review this benchmark data, orientation data, and window glazing performance via window wall ratios. And for each data point that you see here, it is possible to interact with the data and adjust the ranges to suit your building for lighting efficiency or for daylighting or occupancy controls, for example. You choose what kind of efficiency you need in your building. You can see the analysis updating as soon as you toggle between different data points. Now let's take a look at a tool and workflow design optimized for the design development process. Autodesk has intelligent tools that allows engineers to perform complex analysis so that you can understand the behavior of your structures. So that is very important. Once we model a structure, once we get up start once we plan the building, and then when we go before the construction phase, we need to make sure that our structure has the strength and the behavior that is expected to withstand all of the natural forces and all of the forces that is going to be there on the building. So the intelligent tools in Autodesk actually help you perform those complex analysis so you can understand how your structures will behave. You can do this using Revit and robot structural analysis, which has a direct integration. So Autodesk Revit and Autodesk Robot Structural Analysis have direct integration, so you can seamlessly transfer models from one tool to the other. You can model everything in Revit, move it to Robot, run your analysis, make your changes in the structural design, then bring the model back to Revit, which update all of these updates happen seamlessly. You don't have to import anything, you don't have to export anything. It is all seamless. Robot Structural Analysis Professional Software provides structural engineers with advanced structural analysis capabilities, including for large and complex structures. Can analyze models with powerful finite element automation, nonlinear algorithms, and a comprehensive library of country-specific design codes. So Revit can extend BIM to the analysis process. So what you see here is a Revit model. So what happens is whenever you model something in Revit, you generate a 3D model, and at the same time you also generate an analysis model that you see on the right side of your screen. So Revit can extend BIM to the analysis process through an advanced, fully bidirectional link with robot structural analysis to allow designers and engineers to perform structural analysis. Both products are available through the Autodesk AEC collection. This bidirectional link between the products streamlines structural engineering workflows by facilitating the coordination of design documentation with structural analytical design information. As you see here, you can apply all the loads, and then you can go to the robot structure link, send your model to robot, choose the loads and load cases that you want to send, click on OK, and what it is going to do is open robot structural analysis automatically. And now you see the model, the exact same model that you had in Revit, automatically exported to robot. You can see the analysis model here with all the different load cases and the load values that are being applied. And you can also define your own combinations in terms of automatic combinations or manual combinations based on various codal specifications that you use. And once we run the analysis, the system is going to calculate all of your forces, all of your moments for each of the load cases and the load combinations that we specified. And you can visually see those parameters, visually see the forces on your structure or the behavior of your structure on the robot screen. Can also see the displacement diagrams or the reactions for your foundations, reactions for your supports for each of the load cases and combinations directly from Revit. And based on this, you can make modifications to your structural elements or your other elements to make sure that it has the required strength to withstand all of the forces. And for each of the flows, you can also see the flow stresses that are available. See if it is all okay for you, see if it all matches your requirement, see if the flows are up to the strength that is required from them. And you can also see the values of each of those stresses either throughout the flows or individual panels that you wish to see. And can also see animation of how your structure is behaving for those forces in terms of the displacement diagram or the deflection animation. So this link between Revit and robot structural analysis supports the iterative design process and exchange of data between designers and engineers, enhancing collaboration between them for further understanding the value of BIM to structural engineers. The link helps integrate analysis into the BIM process, supporting structural designers and engineers' workflow needs. So we can do all of the activities that you do in a typical analysis software right inside robot. But keep in mind that this model was not created from scratch. This model was exported directly from Revit, where the model was already created. We're just exporting the model from Revit into robot seamlessly and running our analysis here to see if it satisfies all the structural criteria. You can see the design results here, steel design or concrete design, all of those design results can be performed. See all of those design results, and if you want to change a member, you can change those members right within robot structural analysis and calculate your structure again or run the analysis again. And once you've made all your changes, you can come back to Revit, update all your model and results directly from robot. And what this is going to do is all the changes that you made in robot for your structural analysis, they are going to be imported directly to Revit, and it is also going to tell you which sections have been changed. So what this lets you do is it avoids the typical input sketches that is created between the engineering and the design teams to communicate all the design changes. The engineers can run the analysis tools, run the analysis, and the designers can import the analysis model directly into Revit without any data loss or misinformation or miscommunication between the teams. All of the latest changes from the engineers can be imported directly into the designer's 3D model. So this is the power of the integration between Revit and robot structural analysis. And Revit is a BIM-centric solution for the reinforced concrete industry as well, not just steel structure. It is also a central solution for the reinforced concrete industry. So what it does is it helps you better connect concrete designing and detailing to fabrication. Revit provides tools for detailers for modeling 3D concrete reinforcements, creation of shop drawings, and bending schedules in the advanced BIM environment. It combines the versatility of 2D documentation with the higher level of fidelity and accuracy of 3D modeling of reinforcement and concrete accessories with minimal effort to produce both. As you can see, editing the reinforcement geometry in 3D is very easy in Revit, and it adapts to the geometry of your structure that you're designing for. Even if it is a complex shape or even if it's not a regular shape that we use, Revit can still adapt to the shape and change the reinforcement modeling to suit the shape's need. Can specify the cover values directly within Revit, and you can choose to work in either 3D or 2D inside Revit to do your detailings. And if you see here, since all of the reinforcements are connected to the elements, any change in size of the, let's say a beam, and there's a change in size of the beam, the reinforcement, the cover values, all of that, they are adaptive. As the beam size change, the reinforcement also shrinks to adapt to this change in beam size. So you don't have to worry that the reinforcement is going to protrude and you have to do the cleanup activity. All of this that is done directly automatically by Revit. So this is the power of concrete reinforcement detailing inside Revit. What about prefabrication? Prefabrication can lead to more reduced project schedules, greater productivity, and we all know that it also enables better on-site safety records. Structural precast extension for Revit supports for multiple stages of the precast workflow. You can use the solution for planar structural concrete elements of a building, such as solid walls, solid slabs, and hollow core slabs. It offers advanced tools that automate the process of generating precast assemblies, shop drawings, and files for computer-aided manufacturing, that is CAM machines as well. So this will take you one step closer to design and make technology, or design for fabrication and manufacture, where you treat your buildings or treat your construction project as a manufacturing project, and you manufacture individual elements that you can erect at the site. So this will take you one step closer to achieving that design for manufacturing and assembly. So let's move into the other part where you want to do. We spoke about concrete detailing, but what about steel detailing? How do you do steel detailing using the Autodesk AEC collection? For steel, the steel connections from Revit actually preset the shop or field status of the bolts and welds. What this means is that when the connections are imported to advanced steel from Revit, the assemblies are automatically created. What remains for the designer is to set their numbering settings and number the model. That's the only job that is left. Then they are ready to produce the erection and shop drawings. Since because of this tight integration between Revit and Advanced Steel, you capture all of those information into Advanced Steel, and you just have to do this small numbering work. Advanced Steel has a very powerful shop drawing engine, which allows a large range of customization and automation features. This enables steel detailers to match the steel fabricators' preferences for showing things like dimensions, marks, title blocks, and bill of materials layout. You see all of that in action here. See all of these different parts which are automatically created from Advanced Steel. And if there are any modifications in the 3D model, Advanced Steel will automatically detect which drawings need to be updated. You can automatically update the drawing with a revision index and populate the revision table with revision details as well. This streamlined approach by connecting structural design and detailing processes can help reduce waste and inefficiencies in the shop and on site, helping teams to design and detail structural components in less time. And what this all means is it is going to give you less rework. You see all of the different modifications that you can do inside a advanced steel drawing with automatic revision marking. You can see what has changed in the 3D model and what has been updated in the 2D drawing as well. In the detail phase, BIM enables contractors to connect design, detailing, estimation, fabrication, and installation. Powerful tools like this enable users to create coordinated detail models with up to LOD 400 content. In addition, contractors can create detailed fabrication shop spool sheets as well. These models are ready for shop drawing, procurement, ductwork, manufacture, and installation. We can use Revit to extend the design into a fabrication ready detail model. You can also create a BIM based fabrication ready model from scratch using manufacturer specific content inside of Revit. Revit enables contractors to dynamically perform clash detection during the layout. And all of these Autodesk interoperable tools enable contractors to also extend the Revit detail model into fabrication CAD MEP to produce detailed fabrication shop spool drawings. You can see that in action here. With the fabrication CAD MEP, you can draw your model. Routing your layout is pretty easy in fabrication CAD MEP, and you can also add different connectors, different elements to your routing, which is all seamless. And for each of the systems, you can specify different system names and system colors and create isometrics and spool drawings for all of those. And once that is done, you can import this directly into Revit to see how it fits into your building. So you can look for clashes, see how different elements are integrating with each other, the MEP elements and the building elements. And what you see in detail is how Revit enables contractors to create LOD 400 models, which is completely ready for fabrication. You see all of the detailed work that is being done here with hangers, the ducts, and supports for each of the ducts and the pipes that we see here. The integration helps you choose the service that you want to adopt for your routing and connect various system lines together. With automatic routing and filling, you can connect the start and end point of your duct, and it will automatically give you different options that you can use to connect those services together. You see a similar action here where you can automatically create the routing for your ducts. And you can also optimize your pipe designs. So we spoke about design coordination on how you can bring your MEP models into Revit and check for clashes and coordination with the interface with the other building elements. So BIM actually allows you to better coordinate your designs with extended project team by using tools like Autodesk Navisworks. Navisworks allows you to combine design and construction files from various formats into a holistic model for project review, helping you to resolve clashes and errors before the construction begins. Navisworks reads native Revit files, allowing you to move data between applications fluidly. There's no loss in data transfer. You can use Navisworks to combine Revit files across the project and incorporate files from many other common file formats other than Revit file formats. You can also use tools that allow you to see the same clash found in Navisworks in an appropriate Revit model. This makes it much easier to identify and resolve clashes because you won't have to search the entire model. You know where a specific clash is occurring and you can go directly to that point to resolve that particular clash. You don't have to waste time scanning around the model to look for clashes and checking those clashes and modifying those clashes. And with Navisworks, it also helps you create a 4D or 5D simulation where you can bring in your schedule data, project schedule, can import your project schedules from either Microsoft Primavera or Microsoft Project or Primavera, bring them into Navisworks and connect them to different elements in your model and run a simulation to see how your model will progress. You can see your actual versus planned progress or your planned progress or your actual progress. All of that can be seen based on the schedule that you import to see the different activities that will occur at each stage of the project. As you see here, you see what is the month and the date and what is the percentage of work that is being completed with color coded approach to all of that which are completed on time or completed which are running late than the schedule. All of that can be visually seen here for your overall project. So this gives you a complete view to see how your project is going to be constructed and to also track what is happening on the site, to track what is the actual construction that is happening on the site to what you had planned to be constructed during a particular time period. So these are the different tools and solutions that we saw for the conceptual design stage, schematic design stage, design development. So what about the documentation part? As I told you, we're talking about connected BIM, so it is important that we connect all of this data to a cloud platform. So cloud-based collaboration tools are enabling design teams to work in new ways on BIM projects. And we have seen that time and again now, especially in 2020, because of all the remote work that we have been doing, we understood the requirement of a system that has our data on a central platform where we can access the data from anywhere, anytime, irrespective of our location, since we were all working remotely during this year. By centralizing project data in the cloud, all of your firms can accelerate design delivery by enabling teams in multiple offices, even on different continents, for example, to concurrently work on shared models. In addition, this technology makes it easier for architectural firms to work fluidly on joint venture and IPD projects, for example. And Autodesk solution for this cloud-based design collaboration is referred to as BIM 360 at a high level. And this encompasses many different modules. You have many different modules under BIM 360, but the total tool cloud-based design collaboration tool is called BIM 360. Into detail about BIM 360 today. We'll be spending more time on BIM 360 on a separate session. But this is what BIM 360 can do for you. BIM 360 connects data across all of your design phases, right from design to pre-construction to field execution to operation, with all of your project data connected. And BIM 360 can connect to all of your design authoring tools that we saw just now, like Revit, Advanced Steel, AutoCAD, Navisworks. All of those tools, the data that is being created from those tools can be directly accessed through BIM 360. And BIM 360 helps you manage all of the data in one platform so that you can access all of your data anywhere, anytime. So these are the different different functionalities or capabilities that Autodesk AEC collection is going to enable you to do, right from the conceptual design phase to the schematic design to design development and to documentation. And for each of these stages, these are the tools that are part of the AEC collection, which will help you do all of this workflow that we discussed about for at each different phase of the project. And all of these tools that are highlighted in red and a few other tools for the infrastructure space as well. I think we'll be spending more time again on a different session where we'll talk about how AEC collection can help with the infrastructure projects. So there are other tools in the infrastructure segment as well, but these are related to the building industry and what we can do for the building industry using tools that are available in the AEC collection. So that's all from me. Thanks for your time.